Hello, so in this video I'm going to talk about half-angle identities. Um, so the one way that we can look at half-angle identities is by starting with the formula cosine of 2x is equal to 1 minus 2 sine squared x. Remember that this is just the double angle identity. And this is for cosine, written in terms of sine. Okay, so one way that we can actually solve for the double angle identity, and it's a little interesting, is that if, for instance, we were to basically solve for sine squared. So let's say that we have that we subtract 1 from both sides, and then we see like what we end up with. So let's write it like this. So we end up with minus 2 sine squared of x equals to negative 1 plus cosine 2x. But if I divide by negative 2, I end up getting sine squared x equals to 1 minus cosine of x divided by 2. Because again, if we just divide by negative 2, we get kind of like the same thing. So this is what we get. But from here, we have to just really subtract, let's see, we'll have to actually not subtract, but take the square root on both sides. So we'll take the square root, and we'll take the square root. So what this does is it gives us that sine of x equals to plus or minus the square root of 1 minus cosine of x divided by 2. Now what this does is it gives us the half-angle identity formula for sine of x. Now the only difference though is that, okay, that should be 2x, right? Yeah, 2x. Now the only difference is that if I was to let, let's say for example, theta equal to 2x, well then that means that theta over 2 is equal to x. So what that means is that we end up with the following formulas for the half angles. So one of our first formulas is basically just sine of theta over 2 equals to plus or minus the square root of 1 minus cosine of theta divided by 2. But then we have a couple more. We have that if we were to, say for example, go back and use another formula, for instance, for cosine of 2x, which another one would be cosine of 2x equals to 2 times cosine squared x minus 1. So essentially you can probably do the same thing, and you can derive a formula for cosine of theta over 2. So let's say that this equals to plus or minus. Well, the nice thing about this formula is that it's essentially the same thing, except it has a plus sign, and this is divided by 2. Now, interestingly enough, if you look at tangent, tangent gets a little complicated because you have that if you use the original definition of sine over cosine, then that gives you this really interesting expression of 1 minus cosine theta divided by 1 plus cosine of theta. Now, this doesn't really seem very friendly in the sense that, well, you still have to pick plus or minus, and having to simplify the expression and the inside of the square root sign might seem a little challenging. So there is an alternate formula for the tangent of theta over 2. So tangent of theta over 2, it's actually equal to a much easier formula that's a little more manageable. It's equal to sine of theta divided by 1 plus cosine theta. This is actually a lot easier because then in this case we don't have to account for pluses or minuses. And then this is equal to, let's see, well, this is equal to 1 minus cosine theta divided by sine theta. Both of these expressions are the same, so really it's just a matter of preference in terms of like which tangent theta over 2 do you prefer. Okay, so really they both work. Now, one thing that I would like to look at, for example, is a couple of half-angle formulas or half-angle computations. So, for instance, let's go ahead and find sine of 22.5 degrees. So if we try this, well, the main thing that we know is that theta over 2 is equal to 22.5, which means that theta is equal to 45 degrees. That's degrees. Okay, well, if that's so, then we can actually figure out what the computation is. Now notice that theta over 2 is in quadrant 1, which means that we already know whether it's positive or negative. So that's going to be sine of 45 degrees divided by 2 is equal to positive the square root of 1 minus cosine of 45 degrees divided by 2. Now what this gives us is the following. It gives us that you end up with 1 minus, well, think about like this. The right triangle has that you have 1, 1, root 2, and this is 45 degrees. So accordingly, cosine is 1 over root 2, but you've done that so many times that it's root 2 over 2, and all of this is divided by 2. Now, this is going to be equal to, okay, so 1 is the same thing as really 2 over 2, so we can just say 2 over 2 to find a common denominator. So we have 2 minus the square root of 2, all divided by, well, notice that this is all divided by 2, but it's divided by 2 again, which means that it's divided by a fourth. So in that case, we have that it's divided by a fourth. And for those that need to see it, you have 2 minus root 2 divided by 2, but since it's divided by 2, that's why you're multiplying by essentially the reciprocal, which is the same thing. Okay, so what this does is it gives us the square root of 2 minus root 2, but all of this is divided by, what's the square root of 4? Well, it's just 2, so we have divided by 2. Because notice that it's not included in the radical symbol, so we just leave it like that. Now, suppose that I wanted to find a different computation. So let's say, for example, that we look at finding. Okay, so let's try to find sine of 15 degrees. Okay, now in this sense we know what theta over 2 is. It's equal to 15 degrees, but for the most part, most students tend to struggle on figuring out, like, what is theta? Or for some reason, sometimes it actually ends up being like, I don't know what theta over 2 is. Even though it's in the parentheses already, for some reason, it's always like kind of like confusion as to like what is theta over 2. So theta over 2 is actually 15. So that means that theta is equal to twice that, so that's going to be 30 degrees. Now, when we look at this, this is actually very simple because we know that, for example, we know that theta over 2 is in quadrant 1, so that's done. The rest is that we just need to plug it in. Now, if I write theta over 2, remember that that's just the theta value that you're working with, so that's just the angle measure. So this is going to be the square root of 1 minus cosine of 30 degrees, all divided by 2. Okay, so to find what the cosine of 30 degrees is, aside to just using your calculator, well, for instance, this isn't really to scale, but that's okay. So we have 1 root 3, and then we have 2. Now, this right here is the 30 degrees. So cosine of 30 is root 3 over 2. So that's just going to be the square root of 1 minus root 3 over 2, but all of this is divided by 2. So we'll just say that this is going to be the square root of, well, if you use the same technique that I used earlier, it's always going to be divided by 4. So you have 2 minus root 3 divided by 4. And when you simplify this, this is going to give you the square root of 2 minus root 3, all divided by 2. And then that's it. Now, interestingly enough, you may have saw that you can find, for example, sine of 15 by using sine of, let's say, like 45 minus 30 degrees. This is actually the same thing, essentially, but check this out. It looks like this. It looks like square root of 6 minus the square root of 2, all divided by 4. So the question becomes, how did these solutions even equal each other when they look completely different? But if you plug them into the calculator, you'll see that they're exactly the same. Having to show that they're both equal is kind of like a process of trying to rationalize these values, or try to introduce um, like the conjugates in any case. So that's something to look at, but I would, kind of just say the easiest way to show that they're both equal to each other is just to plug them into the calculator, if you'd like to do that. Now, I would like to also look at, for example, how do I find tangent of a half angle measure? So for instance, if I go ahead and I say, let's go ahead and find tangent of 75 degrees, then we can do that too. So to find tangent of 75 degrees, I just need to know that, well, first off, tangent of 75 degrees has that theta over 2 is 75, which means that theta is equal to 150 degrees. Now be careful with this because, for instance, I happen to know that 75 degrees is also in quadrant 1. Okay, so just be careful with, the quadrants and those kinds of things. Now, what this means is that tangent of 75 degrees is actually going to be it's actually going to be positive. Okay, so we can do this very easily. So we have that tangent of 75 degrees, let's rewrite it as 150 divided by 2. And then we're going to put sine of 150. And all of this is divided by 1 plus cosine of 150 degrees. Now, be careful with how you write this because, for instance, I know that 150 is in quadrant 2. So what that means is that the sine is going to be positive, but the cosine is going to be negative. So yeah, just be careful with this. And remember that the right triangle that will help you. Let me do this again. Okay, so we have that this is going to be 1 root 3, and that's going to be 2, and that's going to be 30 degrees. And the reason that it's 30 degrees is because the reference angle is 30 degrees. So what we'll do here is we'll just say that we have sine of 150 is, well, it's 1/2 based on opposite over hypotenuse. Then you have 1 plus, well, cosine of 30 is root 3 over 2. But remember that it's negative root 3 over 2. So what this does is it gives us the following. It tells us that we have 1/2 divided by 1 minus root 3 over 2, which this equals to 1 over 2 minus root 3. Now, when you rationalize this, basically when you rationalize this, you have to multiply by the conjugate on top and bottom. So that's going to be 2 plus root 3 divided by 2 plus root 3. When you multiply this through, this is going to give you 2 plus root 3, all divided by 4 minus 3. So what that means is that the solution, the exact solution is equal to 2 plus root 3. And then that's it. Now, the other things of which that you probably should look at is, like obviously like half angles of cosine functions. But also use reference angles to your advantage because, for instance, if I wanted to look at tangent of, let's say, like 255, well, I know that basically 255 minus 180, that should be 75. So that means that this is equal to tangent of 75 degrees. So that means that you can kind of use 75 degrees as your reference angle, or even 15 as another reference angle, because once you know one, then they're all really the same. And also like look at co-functions. Like for example, we did sine of 15 degrees, but that also means that you would know cosine of 75 degrees. Okay, so in this case, we can use cofunctions to our advantage and also reference angles. So just look at that in terms of like, if you wanted to find other trigonometric functions or other radian measures or degree measures that you can just reference to something else, to some other function. Because that's going to make the computation way better, and honestly, like most of the homework questions ask the same thing anyways. Okay, so let's look at where you have that a given function. So you want to find cosine theta over 2, and we'll just find sine of theta over 2. And we'll go ahead and find tangent of theta over 2. Okay, so we're going to have to give you, I'll give you a little bit of information, for example. So basically I have that there is cosine theta equals to negative 3 over 2. The angle measure is between pi and 3 pi over 2, which means that this is in quadrant 3. But note that if you divide by 2, you get that theta over 2. Theta over 2 is in quadrant 2, which means that sine will be positive, because remember that if you draw the quadrants, that basically we said that all students take calculus, which basically means that you know that in quadrant 2, sine is the only one that's positive. So based on this graph, or based on this information, we have that that should be 3/7, not 3/2. Okay, so let's just change that. Okay, so based on this, what we can do is kind of make a right triangle. That way we have that, we know that, okay, that's 3, that's 7, this is theta, but then let's see, how do we find, let's see, yeah, so actually we don't really need the right triangle, because cosine is involved with all of them. Yeah, I just noticed that. So yeah, if you were going to use Pythagorean theorem, that would be that a squared is equal to 49 minus 9, which is actually equal to 40, which means that a is equal to 2 root 10. So that gives us 2 root 10. But we don't really need it in actuality, because yeah, we don't need the opposite side actually. Yeah, okay, so this is going to tell us that if we go ahead and we look at, yeah, so if anything, if you want to just ignore this, you can. Usually we do need it, but I didn't notice it until I saw that the formula actually asks for just cosine, so we don't really need it. Okay, so cosine theta over 2, it's going to be negative, and you have that that's going to be the square root of 1 plus cosine of 30, or cosine of theta, which is negative 3 over 6, negative 3 over 7. So that's going to be, yeah, so we'll put negative 3 over 7 divided by 2. And this is going to equal to, let's see, so 1 minus 3/7 is 4/7. Okay, so that's going to be 4/7 divided by 2, but that's going to equal to 2/7. So, and it's going to be negative, right? Okay, so negative, negative. And then from here, this is going to give us that if we reduce this even further, you have negative 2 over root 7, but this equals to negative 14, or root 14, divided by 7, and then that's it. Okay, so we found that cosine theta over 2 is negative root 14 divided by 7. Now we want to do the same thing with sine theta over 2, which equals to positive the square root of, so this is also going to be somewhat similar. You have that this is going to be 1 minus 3/7 divided by 2, but this is going to give us 1 plus 3/7 divided by 2, which is equal to the square root of 10 sevenths divided by 2. So this gives us, if we reduce this even further, the square root of 5/7. But this is where it gets a little interesting. Like if you do it the same exact way as where we multiplied by the conjugate of root 7, so that's going to be root 5 divided by root 7 multiplied by root 7 over root 7, which gives us positive 35 over 7. Well, positive root 35 over 7. Okay, so now we want to find tangent of theta over 2. Now, the reason that's why I needed to use this triangle in actuality was for tangent of theta over 2, because I would need sine as well in order to figure this out. But interestingly enough, we already have everything in terms of, you know, the given information, because we have that tangent of theta over 2 equals to, well, we have, it's going to be root 35 divided by 7 divided by negative root 14 divided by 7. But this is going to equal to the square root, negative the square root of 35 over 14. Now, what this does is it gives us 5 halves. So that's going to be negative the square root of 5 halves. But if you reduce this even further, it gives you negative root 10 over 2. Okay, so that looks fine. Okay, and again, if you wanted to use, say for example, one of the other formulas to find tangent, you can. So for instance, like sine was root 2 root 10 over 7. And then you have that the cosine, that's going to give you 1 plus, okay, so 1 plus, and then it was minus 3/7, so it's minus 3/7, which is equal to, let's see, 4/7. Uh, let's see, was it? Yeah, so sine was 2 root 10 over 7, and then the cosine was negative 3/7. So this should be, okay, so 2 root 10 over 7 divided by 4. Yeah, divided by 4 over 7. But this is going to give us, and that's should be minus 1/3. Yeah. So I noticed that the sign actually needs to be negative because earlier we said that theta was in the third quadrant, which means that it's going to be negative. So what this does is it reduces down to negative root 10 divided by 2, which is exactly the same thing. So yeah, when you use this formula, you just have to be careful with that. When you're using the original theta, that you remember what quadrant that was in. Okay, so uh, yeah, just be sure that you keep track of that. So really, this is only good enough for if you're going to just look for tangent given just cosine. But if you're going to use just cosine theta over 2, sine theta over 2, then in that case, just use the half angle formula. Uh, and then from there, because I already had the two solutions, and I just told myself, well, I can just use sine theta. Because yeah, over here, we just used that sine theta over 2 is cosine theta over 2. And then just said that, we can just substitute and then just simplify it rather than do all the algebra to just get this number. So, because I did the alternative method right here. Okay, so that's going to be it for chapter 5. In the next section, you're going to look at trigonometric equations and also inverse circular functions. Um, be sure that you do look at, for example, like cosine of pi over 8, maybe even, for example, like cosine of 5 pi over 12. Try to, basically what I'm trying to say is that you want to look at half angles with respect to their radian measures, because then in that case you can be able to figure out what those are using the same formula essentially. As long as you're kind of like okay with that. Let's see, and then anything else? Well, I think that's it for now. So just be sure that you look at other cosine functions and also some other tangent functions and sine functions using radian measures. Okay.